For the last part of quadratics, we need to talk about how to read graphs and the applications of these quadratic functions. So for example 1, a rocket is launched from a hilltop 240 feet above the desert with an initial velocity of 40 feet per second. This situation can be modeled by the function h of t equals negative 16t squared plus 40t plus 240. The graph is shown. So first, before we look at the questions, let's look at our graph. So I have my labels on my axis. So my x is representing the time in seconds after the launch of this rocket, and my y is representing the height in feet. It does give me tick marks of how these are being counted, so let's go ahead and fill in our graph with these extra tick marks. So the x's are going by ones, so this will be a 2, 3, 4, 5, 6. Y's are going by 25, so that means the next one has to be 50, then 75, then 100, then 125, 150, 175, 200, 225, 250, and I believe this one would be 275. Okay, now let's start looking at our questions. So the first question asks us, what is the maximum height of the rocket? So this is all about reading a question and figuring out which part of this graph, the function, does it want. Well, I see that it's asking what is the maximum height. Well, that's going to be the vertex of your quadratic function. So my vertex, and we're going to have to estimate, is about right here. Now we need to decide, this is a coordinate point. Do I want the x value or do I want the y value? So if it says what is the maximum height, that means I want the y value, because that's my height is on my y-axis. So we're gonna have to estimate a little bit. So this is somewhere around 270. So about 270, and make sure you put feet. Make sure you give a unit because 270 could mean just about anything. Now question 2. When does the rocket reach its maximum height? Well, it's still talking about maximum height. So it's still the same point, but now it's asking when. Well, when means time, which means I want the x value. So same point, but now we're going to go down towards the x-axis and figure out about how long did it take to hit that maximum point. So this looks about 1.3 seconds. And again, make sure you give units. Don't just say 1.3. Number 3, approximate the height of the rocket at 2 seconds. So it's telling me that I want 2 seconds and it says approximate the height. So that means I want to know, approximate the height means what is y when x is equal to 2, because that's your seconds is your x. So we're going to go to 2 on the x-axis, find where it hits my graph and plot a point. So here's where the rocket is at about 2 seconds. And then we're going to approximate its height. So since I need height, I'm talking about the y again. So I'm going to go towards the y-axis. And it's approximation. So this is about, let's say, 255 feet in the air. So you may not have the same answer as everybody else, and that's okay. What I shouldn't be getting is like 300 feet, because 300 is clearly too high. 300 is way up here. I also shouldn't be getting 175 because that's too far down to the bottom. As long as you're around this area, that's why it's an approximation. It's not perfect. Number 4, when will the rocket be at 100 feet? So again, when will, so that means you don't know time. So you're looking for x, and it says 100 feet. Well, that's your y. So same idea. They're telling me that y is 100. So on my y-axis, I'm going to find 100, move over till I find my graph, and I'm going to plot my point. And I want to know when does this happen. So I'm going to go towards my x-axis to figure out when does this actually hit 100. So it looks to be about 4.5. It looks kind of right in the middle. So about 4.5 seconds. Okay. Number 5, at what time will the rocket reach the ground? So this one can be tricky only because of this reaching the ground. Sometimes we feel like I don't give you enough information. Well, think about what ground level is. Ground level is when your height is 0. So I'm telling you that y is actually 0, and I want to know at what time. So that means, well, what's x? How long does it take to actually have this rocket reach the ground? So let's look at our graph. Find your ground level point, which is right here on the x-axis, because that is when y is equal to 0. And then when does this happen? Well, that's about, what, 5.2? So we can say that it hits the ground at about 5.2 seconds. And lastly, what is the domain and range for this situation? So domain always deals with your x value. So in this case, domain is all about time. Well, the smallest time this rocket has is 0. I can't have negative time. Then I need to figure out the highest time. So how far does my rocket go as far as time is concerned? So it starts here at 0 on the x, and it goes all the way till the rocket reaches the ground. So the time that it reached the ground is the ending time, and we said that that was at about 5.2 seconds. That's when it reached the ground. So that's the highest time this rocket will be in flight. So 0 is the smallest time available. 5.2 is the highest time available. Then range is your y, so this is dealing with height, and it's always low to high. So the smallest height my rocket can have is 0, because that's ground. Your rocket's not going to go underneath the ground. So it stops at ground level, which is 0. And then we need the highest height, the max height, which was this point here, which we calculated in number 1. The maximum height of the rocket was about 270 feet. So that's the highest range value possible. So we're going to put 270, so less than or equal to 270. Let's try one more. So example 2, a swim team member performs a dive from a 14-foot high springboard. The parabola to the right shows the path of their dive. So again, start by analyzing your graph and seeing what you have. So I have a parabola shape. Now, x is the distance from the springboard in feet. Y is the height that this diver is getting in feet as well. My x's are going by ones. Yes, it shows 2, 4, 6, but in betweens, this is really 1, 2, 3, 4, 5, 6. Y's are going by 2's, 2, 4, 6, 8, 10, 12, and so on. So now let's see what the questions are asking. So number 1, what is the height of the springboard? So you can actually get this in 2 places. So if you want the height of the springboard, that means your distance from the springboard has to be equal to 0. So that's really talking about the y-intercept. So the y-intercept is here at 14. So the height of the springboard is 14 feet. You can also get it from the description of this situation. Performs a dive from a 14-foot high springboard. Either place is fine. You just have to make sure you find the correct information. Number 2, how far away from the springboard does the diver land in the water? So land in the water, how far away from the springboard? So landing in the water, think about your height. Landing in the water, your height is 0. So that's telling us that I know that y is 0. If it's asking how far away, that's your x value. So let's go to the graph. Find where your height is 0 on your graph, and it's this point right before 8. So it's not going to be exactly 8 feet away. So we are about 7.9 feet away from the springboard when you hit the water. Number 3, how far away from the springboard is the diver when they are 16 feet in the air? So again, how far away from the springboard? That's your question. So that means you're trying to find what x is. And then what are they giving you? They are 16 feet in the air. So they're telling us that y is equal to 16. So let's go to our graph. Find where y is equal to 16. Well, here's where y is 16. If you notice, here the graph is y is 16, but it's also 16 on the other side of the parabola as well. So this time there are two places that the diver will be 16 feet above the water. So we need to take both of those. So for the first point, the diver first hits 16 feet above the air when he is about 0.2 feet away from the springboard. Then he hits 16 feet in the air again when he is about 5.8 feet from the springboard. So he actually hits the 16-foot mark twice at about 0.2 feet away and at about 5.8 feet away. So if it does hit a point twice, you need to make sure you include both of those points. Number 4, what is the maximum height of the diver? So maximum height is what we're looking for now. So let's go to our graph and find the max point and mark it. So our maximum point for this graph is here. Now it said, what is the max height? Well, that's your y. So the max height, so let's see, 22. So that's about 23 feet in the air. So that's the highest this diver is going to go. So about 23 feet in the air is his maximum height. Now, number 5, how far from the springboard did the diver reach their maximum height? So same point, I'm still talking about a max, but now I want how far from the springboard. So now I want my x. So let's go back to our graph. Maximum height was 23, and he hit that maximum height when he was about 3 feet from the springboard. So about 3 feet from the springboard. And last but not least, let's talk about a reasonable domain and range. So domain deals with our x's. So in this case, this is dealing with distance away. Okay, so the smallest distance away from the springboard is 0. That happens when you're actually on the springboard. Less than or equal to x, less than or equal to. Then the furthest away from the springboard you can get is when you hit the water. So that's that pink point. So we have at the springboard, and then the furthest away I can get from the springboard is when you hit the water. And we said that that was at about 7.9 feet. So that's your maximum for your x values. That's the furthest away from the springboard that you can get. So 7.9. Now our range, that's our y values. So in this case, this is the height of the dive. So the smallest height is 0. That's when you hit the water. The largest height, the max height, well, we said on number 4 that that was about 23 feet. That's the highest this diver is going to get. So that's our ending value. Smallest is when you hit the water. Largest is the max height at the top.